So the most important one is the time shift. You need to know how to calculate the time shift signals. And here I give some proof in the properties. So in the last two topics, I have introduced how to prove the properties. The key step is you translate the conditions and conclusions by mathematical expressions, and then you see how to bridge these two together and find the solution. All right. So now the condition is the xj is the z transform of the input signal. It is xn un. So from the definition, so this is the condition. And conclusion is whether these two are the same. So how do we think about this? So it means if the signal now it is so first we can write down the Z transform of this one. It is equal to and then we need to check whether it's equal to the x minus z, right? So what is the x minus z? Look at here, this is the definition. So here the changing variable is z, and x minus z, it is just changing z, all of z by minus z, right? So here, only this position has z. So it's equal to So now the conclusion is whether this one is equal to this one, right? What? Oh, so sorry. So whether the problem now is whether these two are the same. So here we find this one, the domain is the same, and this one, this part, both two have this part, and difference is this part, right? So very easy, you just combine these two together, it is equal to minus j. Minus n. So now it is same as this one. So for proof, we can write down by this direction. First write down the thesis form of the new signals, and then you just combine these two together, so we get down arrive this conclusion. All right. So the step is easy. You just translate the conditions and conclusions by mathematical expressions, and see how to bridge these two. Any problem? So the second problem, you can use similar methods to find it. Okay, so now is the expression, find the response of the differential equations. So for this kind of problems, we also have three standard steps. One is time shift. Second one is you apply the transform, and then find the inverse transform. So why do we need to time shift the equation? Okay, so here we find the input actually it is a causal signals. It only has value when n is larger than 0, right? So the so for this systems, we want to know what's the result, what's the output from n equal to 0 to infinity. We want to know what's the y0, what's y1, y2, and so on. Right? But here, actually, but this question actually has some initial conditions. If we just put the n equal to 0, so here it is y2, this is y1, this is y0. So in this case, there's no y2 and y minus 2 and y minus 1, right? So we need to time shift because we want to, the output, it should have some effect of the initial conditions. But if we just using n equal to 0 to infinity, so there's no effect of the initial conditions, right? Okay, so for n equal to 0 to infinity, so here we have three output response, yn plus 1, n plus 2. So actually we have three, if n is equal to 0, so this should be yn plus 1, yn plus 2, right? If there is no initial conditions, so we can just calculate these three parts. So this is in the causal systems. It just have value when n is larger than 0, right? But here it has some initial conditions, and this one it cannot capture the effect of the initial conditions. So we need to shift this one. Okay, so this one actually is equal to yn minus 1. This one is yn minus 2 here. Okay, so from this equation, it means this one is it is the effect of this 2, right? Because yn minus plus 2 is the combination of these two response. So these three are always in the one group. Because we want to capture the initial conditions, so we need to shift to the left to here. In this case, the yn minus 2, when n is equal to 0, it is y minus 2. And then we have the initial conditions. So we can put in the initial conditions. Right? So originally it is yn, and now you shift to the left. Now it's yn minus 2 here. So for this equation, we just shift to the each one with minus 2. So we have this one. So now, when we analyze the output, when n is equal to 0, so this part, it has the value of the initial condition y minus 2, right? And when n is equal to 0, so this is y minus 2, this one is y minus 1, this is y0. So you have these two conditions, you have these two equations, so you can calculate the output, right? So because we want to capture the effect of the initial conditions, so we need to time shift of the original differential equations. Any problem about this part? All right, so this is very important. So here, original equation, you have these three parts, but you need to capture the effect of initial conditions. So you need to shift here. And then in this case, when n is equal to 0, it has the initial conditions. All right, so now we have these new equations. And we need to find the output of this one. So because we just want because this is causal systems, here the xn is a causal signals. So we just want to know the causal output. So we can times by un. The left hand side times by un, and left hand side times by un. So it means we just want the output of the causal signals systems here. And then for these three parts, for all these components, we find the Z form. This one is easy, but this one, yn minus 1, un, you need to know, you can decompose this one by un minus 1, and then plus delta 1, delta n here. In this case, this is time shift of the yn un, and this one is easy to calculate. Similarly, this part we can use in the similar techniques. So this technique is I've mentioned many times how to calculate. All right. So here we find the three. In the left hand side, we have the three components. And this part, you have the effect of the initial conditions. Here, y minus 2 and y minus 1. And also from the left-hand side, we can use the similar techniques to find the Z form. And then you can calculate yz right here. So to find the original output, also we need to use the inverse form. So first step is yz over divided by z, and then times by z, and then find the inverse form. All right. So in this problem, yes, you need to know several problems. One is time shift. How much time shift you need to perform so as you can capture the initial effect. And second, after your time shift, you just times by un, because you just want the causal output here. And then using the Z form. Here, Z form, you need to know the property of the time shift when it has this kind of component. How to calculate its Z form. Okay, so these are the three key components here. We need to be careful about these three parts. Any problem about this one? Right, so the last one. So in this course now we know how to express a systems. There are many expressions. One is the differential equations. For differential equations, sometimes you have initial conditions, sometimes it has not. So you can use the Z form or the Laplace form to find the response. And second one is the characteristic mode. So this one is to capture the geo state response. So when it has no initial conditions, so this one is to calculate geo state response. So it just have the effect of the systems and signals. And third one is impulse response. So it can represent systems. And last one is the realizations. So last time I introduced, it has three realizations: the transform 1, 2, and transpose. Okay, so let's see. And another part is, now you have the system response transfer function in these forms. So how do you understand how to represent by this part? So last time I've introduced, firstly, you need to express this one by two system cascaded systems, H1 times by H2. Especially X1 is this part, X2 is this part. So if you can express these two systems and then just cascade it together, so this is the final systems. And this one is very easy. It's this one. And this one is a little more complicated. And I have introduced how to find it last tutorial. So this is the H2 here. And then just cascade them together. So this is the form 1. For form 2, you just reorder this, translate the order of these two systems. Because here it has many delay components here. For example, if there's n, so this is 2n here. But if you can change the order of these two systems, so actually now you just have n delays component here. So it can save cost. So this is the form 2. Okay. And for the transpose 1, you can refer to the lecture. Actually, it has the form, single form like this one. All right. So look at this problem. So this is the transfer function of the system, and this is the input. The first question is to find the tail state response of this system.